Hi, ladies and gentlemen. We are going to have a video lesson that's going to introduce a new concept that I am talking about in lesson 13. This is day 1. And I wanted to give you a nuts and bolts lesson minus the meat, just so that you can refer back to this concept because it is new. So, what we did in class today is we went through pages 118 and 119 in your instruction book. And so I'm going to go through that with you now. Previously in lesson 12, we learned how to locate positive and negative numbers on the number line. And now we're going to learn about this idea of absolute value. So we know that elevation can be a topic of real life situation where positive and negative numbers occur. So the elevation of an object tells you its distance above or below sea level. Negative numbers are used to represent elevations below sea level. Positive numbers are used to represent elevations above sea level. The table below shows elevations of 4 objects, and we are going to graph their locations on a number line and then describe and talk about the distances of the objects above and below sea level. So you can see that we have a picture here of a mountain, and we have the ocean here, and the mountain actually goes into the ocean. So we have elevation being measured in kilometers, and we have that it's 2 kilometers high. The fish is swimming -1 kilometers into the ocean, and there is a sunken ship -4 kilometers, and an airplane flying at 4 kilometers in the air. So we have here, and this is actually in your instruction book, page 118, a number line. And what you notice about this number line is it's actually turned on its end, so it is vertical and not horizontal. That's really useful when we're dealing with elevation, so we can see the same kind of picture that we have up here, and we can actually use our numbers to represent where these objects exist as they relate to this sea level, which is 0. So sea level is marked and labeled already on our number line. We have to now place the objects and elevations listed in the table on the number line. So I'm going to take my pen here and start with our mountain. The mountain is 2 kilometers. So I'm going to know that I'm going to need at least 4 tick marks in both directions, just knowing about my numbers that I'm seeing. And so I'm going to put my numbers on here as the objects are above sea level. I'm going to represent them with positive numbers. And as my numbers are going below sea level, I'm going to represent those as negative numbers. So I have my number line here. And now I have to mark where the objects are. So where is the mountain? So I'm going to use a different color here. So my mountain is going to be at 2. I'll just draw a little picture there for kicks. My fish is swimming here at -1. So here's my little fishy. My sunken ship is lower into the ocean at -4. So here's my sunken ship. Okay, that's supposed to be a little, there we go. And then my airplane is flying at +4. So there's my airplane. So we have marked and labeled the elevations of our 4 objects. How far above the sea level is the mountain? So if I look at the sea level's there, it is going to be, the mountain, is 2 kilometers. I'll change my color so you can see it. 2 kilometers above sea level. The fish is only 1 kilometer below sea level. Is the airplane above or below? Well, it's not flying in the water, so it is above sea level. And we need to find two objects that are the same distance from sea level. So I'm looking for something that is the same distance above sea level as it is below. And if you are noticing that the boat and the plane are both 4 kilometers away from sea level, you are correct. So the airplane and the ship are both 4 kilometers away from sea level. The sea level is at 0. How do I know that? We have that distance 1, 2, 3, 4 in the positive direction being compared to the distance 1, 2, 3, 4 just in the opposite direction. So they are 4 and -4, like we learned in lesson 12. They are opposites. Opposites have the same distance from 0. So when we're explaining how we can find the distance of an object between sea level, all I'm doing is counting the units on the number line. So I'm using that visual of the number line to count the units to tell which one is far away from 0 and how many units that is. Okay? Count the units above or below 0. Okay. So let's continue this conversation. And when we are answering how far an object is from sea level, we have found what's called the absolute value of a number. So here's my definition of my new vocabulary word. The absolute value of a number is its distance from 0 on the number line. There is a new notation that you've never seen before that means absolute value, and that notation are 2 vertical lines that are around a number. So you can notice that it's typed out here, and I rewrote it over on the side. The absolute value of -4 is noted with those 2 lines that are kind of like fences right around that number. So what we saw in our picture is that -4 is 4 units from 0. So we can tell that the absolute value of a number is the positive version of that number. So it is the number of units it is away from 0, and we are measuring distance. So when we see this notation, it's asking us to actually tell how far away that number is from 0. That's why you see it equaling the positive form of that number, because distance is always a positive representation. So this is what this is saying as well down here. Absolute value represents distance. So its value is always going to be greater than 1, which is a positive number. It could be equal to 0. So meaning that the absolute value of 0 is 0, but otherwise it's going to be a positive number. The farther a number is from 0, the greater the number's absolute value. So that means a number like -4 could have a bigger absolute value compared to, say, positive 1. Because we're measuring the distance away from 0, this statement means the farther a number is from 0, the greater the number's absolute value. So negative 4 has a greater absolute value than positive 1, because 1 is only 1 unit away from 0 compared to negative 4, which is 4 units away from 0. So it is possible to have a negative number have a greater absolute value than a positive number. It depends on how far away the number is from 0. So in real-world situations, the absolute value of a number is often used to describe the situation. So instead of saying negative 1 kilometers, we're just going to say, hey, he's 1 kilometer, and then note whether it's above or below sea level. Instead of saying, oh, the ship is negative 4 kilometers, we're going to actually say that, hey, it's 4 kilometers, but it's below sea level. So that notation, we're using that absolute value form of 4, and then just noting, hey, it's actually below the water's surface. So absolute value, new concept. That's why I'm giving you that notation and video in this form. In class, we're going to do some chat racing. So I'm going to just go over these answers. The absolute value of negative 100 is going to be the positive form of it. So the notation is with those two lines, and that is going to be positive 100. So we did that in a chat race. Then we found the absolute value of 5. Again, the notation has that 5 kind of fenced in with those two vertical lines, and it is the positive form of the number. So now we're going to start to compare absolute values like we were doing with negative 4 and positive 1. So these two numbers are being compared with their absolute value. So when we write that, we're going to put those numbers in the notation. And negative 30 is 30 units away from 0 compared to the absolute value of positive 15 is only its positive form of 15. Therefore, which one has the larger absolute value? Negative 30 has the larger absolute value. And we went over that in class. So we are going to compare 40 now, the absolute value of 40, that's how you write it, compared to the absolute value of negative 25. So 40 is 40 units away. Negative 25 is 25 units away. Therefore, in this case, the positive number is farther away from 0. Remember, distance is never negative. So what we're going to also find as we close is that sometimes we're going to see letters representing different numbers. And when we have a number line, sometimes we can use the reference of 0 and this notion that we're going to be dealing with integers in this case. So all of these are whole numbers. And we can then kind of build the number line from what we know about number lines we've drawn. So if this is integers, this would be negative 1, this would be negative 2, negative 3, and negative 4. So we could write in our numbers as they're appearing on the number line, or we can use the idea of which one is farther away from 0. Okay, so I'm going to actually do that. So knowing that we have these numbers, yes. But now let's just look at how they are in relation to 0. And we are going to figure out which number has the largest absolute value. Which number is farther away from 0? Visually, hopefully you see that A is farther away from 0 than B or C is. And again, you can think about the numbers or you can just look at it visually. Now let's think about which number, A, B, or C, has the smallest absolute value. So the smallest absolute value means we're going to find the one that's the closest to 0. So this is only 1 unit away compared to our 2 units for C and our 4 units for A. So therefore, B is the smallest absolute value. A was the biggest absolute value. So that is it in a nutshell, what we learned in class. Again, I'm going to be in a meet teaching this as well. I just wanted to give you the nuts and bolts for you to refer back to in an easier way. So thanks so much for listening. Bye-bye.